So now we're going to talk about completing the square. But before we do that, let's talk about a method for completing the square. Um, to make x squared plus bx a perfect square, what you would do is you would add b over 2 squared, which is the square of half the coefficient of x. This gives the perfect square, x squared plus bx plus b over 2 squared, which is the equivalent of x plus b quantity squared. So it may not make any sense right now, but let's go ahead and look at an example so we can figure out what it is that we're talking about. Okay, so the important thing here is that we want to move this 8 to the other side because we want x squared plus bx to be left alone for just a minute. Now, you might wonder, and could I just factor this? Because I can almost bet that this one right here is probably very, very factorable, and you might already have the answer if you factor it in your head. But let's use this elementary example to talk about completing the square. All right? So what we're going to do is we're going to say, okay, then I have x squared minus 2x. All right, I'm going to leave a space here, and I'm going to set it equal to 8. Now, what did I just do? This minus 8, I added 8 to the other side, and there it is. So nothing's really happened other than what I did to one side, I did to the other, and that's how I ended up with this. So now what I'm going to do is follow my own steps, and that is to say that I'm going to add half of the b coefficient, and I'm going to square it. So what is half of negative 2? Well, for right now, we can write it as negative 2 over 2 squared. And remember, what you do to one side, you have to do to the other. So let's do that. Negative 2 over 2 squared. Now, fortunately for us, we are not left with any kind of fraction. We are left with negative 1. So I'm going to do this. I'm going to say, okay, x squared minus 2x plus negative 1 squared equals, now notice I didn't bother squaring it because I'm going to perform a little trick right now. But let's go ahead and simplify the right hand side, okay? Now what I need you to understand for a minute is that this right hand side is not the equivalent of this right hand side. This right hand side right here is actually the transformation of the left hand side. So let's take a look at it in practice. All right. So we have 8 plus negative 1 square. And what is 8 plus negative 1 square? Well, negative 1 square is 1, and 8 plus 1 is 9. So I'm going to write 9 right there. Now, if you see this right here, I'm going to use this concept right here and make this transformation. That is to write this as x plus b quantity squared. All right, so what are we going to do then? Okay, let's write it like this. Okay, let's write it like this. We're going to write it as x minus 1 squared. And this actually is not b right here. Now that I think of it, it is b over 2. Okay, so it's b over 2. So it's actually x plus b over 2 squared. So notice I can just pull it together, x minus 1 squared, set it equal to 9. Well, now this should look very familiar. Okay, what property can I apply to solve this quadratic equation? Well, if you've seen one of the previous videos, you know that we can apply the square root property. So let's go ahead and do that. Let's take the square root of both sides. So now this is going to leave me with x minus 1 equal plus and minus, well, what's the square root of 9? 3. So I'm going to add 1 to the other side, and I'm going to cancel this one out. X equals 1 plus and minus 3. In this case, x equals 1 plus 3, or x equals 1 minus 3. And what does that look like? Well, either x equals 4 or x equals negative 2. So these are my two possible solutions for this quadratic equation. And again, like I said, we could have probably factored this, and we definitely can factor this now that we know what the two x's are. This was very factorable, but a simple example for completing the square. So let's go ahead and take a look at maybe one more example, and hopefully this makes this very clear. So let's take a look at another example. All right, let's take a look at this one. Let's see, I think I can come up with it. X squared plus 10x plus 16. This one's pretty easy. Equals 0. So this one is also very, very factorable. All right. Okay, so what we want to do, x squared plus 10x, I'm going to set this to the other side, and I'm going to add half of the b coefficient. Well, what is that? What's 10 over 2? That's right, it's 5. So I'm going to do that to both sides. So this right here is just 5. So I'm going to say, okay, x squared plus 10x plus 5 squared equals negative 16 plus, and then remember this was 5 right here. 5 squared is 25. So I'm going to pull this together using that trick. And I'm going to say x plus 5 squared equals negative 16 plus 25. Again, we get something that equals 9. And again, we can apply the square root property. So we apply the square root property, and I get x plus 5 equals plus and minus 3. I'm going to subtract 5 from both sides, get this to cancel. X equals, in this case, negative 5 plus 3, or x equals negative 5 minus 3. So when we solve these two elementary equations, x equals either negative 2 or x equals negative 8. And again, this quadratic that we started with was very, very factorable. So here are two examples of where we learn how to complete the square.